Hello everybody. Let's do some classwork solutions. We will derive the parabola for person A, where we're going to find all the points equidistant from the point -3, 5 and y equals 9. I'll try and highlight important thoughts that you have along the way that help you decide what it is that you're going to do. Okay, so we start with a generic sketch. So there's the line and there's the point. An important part of the generic sketch is putting in a generic point xy that satisfies this condition. And it doesn't have to be exact, but let's just eyeball a point that's approximately the same distance from the point in the line. Obviously, we could put one that's exactly halfway. The reason that's a bad choice for a generic point is because that point is in a special situation where the distance to the point is vertical and the distance to the line is also vertical. So that just might mislead us about generically what's the right way of calculating the distance. If I put a point over here, for example, now I can see, well, so it wasn't a terribly good point because this looks like a longer distance. But we can see that this is a more representative point of all of the points that satisfy the condition, because calculating this distance 1 here, it's a diagonal line, so we're going to use something like the distance formula, whereas this distance 2 is always vertical. So that'll just help us set up the equations right. So now we've got this generic sketch with D1 and D2. If I'm going to restate my geometric statement with algebra, I'll say that we want all of the coordinates where distance 1 is the same as distance 2. And now I can substitute in expressions for how do I find distance 1 and distance 2. So distance 1, we'll just use the distance formula. It's going to be the difference between the x coordinates for our generic point xy and for this point at -3, 5. So I'll say x minus -3 is x plus 3. And then I'll have y minus 5. Both those are squared, and then I take the square root. For this vertical distance, this entire height, let's see, I want that distance there. So if I have the entire height at 9, and I subtract that distance up to my point at a height of y, that should leave that middle bit left over. So I'll have 9 minus y gives me just that distance between y and 9. Okay, so phase 1 is done. I've kind of set up my equations. This is actually, if you type it into Desmos, you will see a parabola. So this equation does give us a parabola, but it doesn't look like a parabola. So now we want to restructure it so it has the form of a parabola. Part of this is going to be getting rid of the square root, and then we'll expand parts where we think some of the terms are going to cancel each other. So let's square both sides. Okay, so I see y's on this side and y's on that side. So if I expand both of these, I'm hoping that I can combine them together to simplify. Because this is the only term with x's in it, it wouldn't make sense to expand this one. So let's just expand the y terms. All right, there we go. Let's notice what cancels. So if I subtract y squared from both sides, those are gone. Let's move all the y's over to the right and everything else over to the left. So I'm going to add 10y to both sides. So when I do that, that will go away. And if I add 10y to this side, it'll give me -8y. Now I'll subtract 81 from both sides. So that'll be gone. And so then this side will be 25 minus 81, which I don't want to think about right now. We'll do that in a second. Great. So we can see that it's starting to have the shape of a parabola because we know that a parabola is going to look something like, let's do it over here, y equals something x minus something squared plus something. Like that's the vertex form of the parabola. So here I've got an x plus 3 squared, and it looks like there's no leading coefficient, or rather the leading coefficient is 1. And then this 25 minus 81 is just that constant on the outside. So let's divide through by -8. I'm going to swap sides here. So I'm going to divide each of these terms by -8. So here I've got -1/8 x plus 3 squared. And then, okay, let's think about this one. All right, that should be negative 56, but then I'm going to divide it by negative 8, like that. And of course, 56 divided by 8 is just 7. So, and I moved the y to the other side. Okay, so putting it all together, negative 1/8 x plus 3 squared plus 7. Okay, let's go back and think, does that kind of fit our expectations for the original conditions? Originally, this was the point and that was the line. So I know that the point that's exactly halfway between the point and the line should be on the curve. And let's see, negative 3, 7, which is the vertex for this form, negative 3, 7 is that exact point. It's halfway between this and the line, and it's got an x-coordinate that kind of lines up with that point. Because I have a negative coefficient on the outside, I know it's an upside-down parabola, which also matches what would make sense for the original geometric condition. So I think that all makes sense. Okay, let's move on in the classwork.